The last skill we're going to talk about in this review unit on equations is solving equations by clearing fractions and decimals. So let's write the word fractions here, and then let's talk about a couple of these warm-up problems here. It says rank these equations 1, 2, 3 from least difficult to most difficult. So 1's going to be pretty easy. We'd do that one first, and then 3 we'd probably want to leave that. Well, if you look at these 3 equations, this one has some big numbers, but I'd probably want to do that one first. So we're going to rank that one 1. And then if you had a choice between doing this problem right here, yeah, it's got some ugly fractions in it, but this is kind of a mess. Look how many decimal places there are. That just looks pretty horrible. So I would probably want to do this one and then this one. And I'm hoping that's the way that you would want to do these. I'm really hoping that you would rather work with fractions than work with decimals. So we're going to talk about some of the problems with working with decimals and with fractions, and then maybe how we can avoid those. Most people don't like working with fractions unless they have to. And it's really not that decimals are really that hard. It's just that there's more stuff that we have to do in order to deal with fractions than if we were dealing with integers. So you might want to stop and think, do you remember what an integer is? Well, remember, an integer is a positive and negative whole number including 0. So those are really nice numbers. Those are about as nice as we can possibly get. But if you had to choose between fractions and decimals, fractions really are the way to go because decimals have their own problems. The minute you have a decimal in a problem, you're pretty much stuck using a calculator. It's pretty tough to do all that arithmetic, keep track of decimal places and stuff like that without using a calculator. We're really prone to making mistakes. So what if there was a way to get rid of fractions and decimals altogether? Well, there is, but it only works when fractions and decimals are in an equation. Okay? Now, I'm going to circle this again. This technique that we're going to talk about only works when you're dealing with an equation. If you try and do this with an expression, remember the difference between an equation and an expression? An equation has an equal sign in it. An expression doesn't. So if you try and do this technique, if you try and clear fractions from just a plain old expression, you're going to get the answer wrong. So please make sure you're careful. Now, you may recognize this one right here. We actually did this problem in the warm-up part A. We did that in the last lesson. We talked about that just a little bit. But here's how we can clear fractions and make sure that we're really good at this. So I've got a couple of examples where we're clearing fractions, several different types here. But again, notice that we're dealing with equations. This is why we can get rid of the fractions, because it's an equation. So here's basically what we want to do in this little box. We want to multiply both sides of the equation. There's that word again. Want to emphasize, got to deal with an equation on these. We want to multiply them by a number that will cancel off all the denominators. So what we want to do here is we want to multiply by the LCM, the least common multiple of the denominators, or sometimes we might call it the least common denominator. So if we were looking at these and trying to get the least common denominator for all of those, we'd look at this and say, well, we've got to have a 2, a 4, and an 8. Now, we don't just multiply all those together. We want to find the smallest number that would cancel those off, that they would all go into. So the smallest number that will cancel all of these off is going to be an 8. An 8 will cancel off a 2, an 8 will cancel off a 4, and an 8 will cancel off an 8. Now, please be sure, I'm going to put a double star by this one right here, please be sure that you distribute through on both sides correctly. What this means is every term on both sides gets multiplied by the same number. So what we're going to do on this side is we're going to multiply this side by 8, and we're going to multiply this side by 8. Now notice this takes care of itself right away. This is just going to be the 8 is going to cancel with the 8. And remember, if there's a fraction in the problem, you might as well think of everything as a fraction. So notice that this looks like it's in the numerator because it is. So we can go ahead and cancel those off. They cancel to be a 1. So we've got a 1 on this side. And then what we're going to do is we're basically going to distribute through here. And I'm going to show a little bit of extra work on a few of these. This is basically saying 8 times n over 2 minus 8 times 1 over 4. Now again, I'm going to make this look like it's a fraction, so we've got the 8 over 1 times the n over 2, and I'm going to do some cross-canceling. I'm going to cross-cancel the 2 with the 8. 2 goes in here once, 2 goes in here 4 times. We're going to do the same thing over here. 4 goes in here once, 4 goes in here twice. So this is a 4 left on the top and an n left on the top, so this is going to be a 4n over here, and the only thing left out of this entire thing is just a 2. Now, you might be able to look at this right here and say, well, if this is 8 times 1/4, 1/4 of 8 is 2, and there we go right there. Just like 1/8 of 8 would be 1 on the other side, and half of 8 would be 4. So there are some quicker ways to do this, but this is basically what's happening. We're distributing that through and we're multiplying every term on both sides by that same number. So when we get to here, now it's pretty easy. We're just going to go solve this like we normally would. And we end up with 4n on this side. And we end up with, let's see, we end up with a 3 here. And then we finish it off by dividing. So we end up with n equals 3/4. Now the interesting thing about this is we started off with fractions. We got rid of the fractions basically in this one multiplying step. And then we ended up with a fraction in the end. So even though the answer worked out to be a fraction, we didn't have to work with fractions in the middle. Okay, so this ended up being easier solving, easier arithmetic, easier steps to solve that equation. So we're going to turn our attention to this guy right here, and we need to cancel off a 3, a 2, a 6, and a 9. So that might take a little bit of thought. So let's think about that for just a minute. So what would cancel off a 3 and a 2? Well, a 6 would, and a 6 would cancel this off, but a 6 isn't going to cancel off a 9, so we need something a little bit bigger. Okay, and if we did a 9 here, it would cancel that off, but watch what happens if I multiply this one by 9. 3 would go in here 3 times, and 3 would go in there twice, so we're still left with the denominator. So again, we're looking for the least common multiple, the least common denominator for a 3, a 2, a 6, and a 9. What could we multiply by? What's the smallest number we could multiply by that will cancel off a 3, a 2, a 6, and a 9? Well, a little hint here is to start with the biggest one. If it's not that one, go with the first multiple of that. So this would be 9, then 18, then 27, then 36, and so forth. Well, if we stop at 18, would 18 cancel off a 9? Sure it would. Would it cancel off a 6? Yes, it would. And would it cancel off a 3 and a 2? Absolutely. So we're going to multiply this side by 18, and we're going to multiply this side by 18. Now, it doesn't really matter if you put the 18 in the front or the back. We're still going to distribute through. Remember, it's this idea that each term on both sides gets its term being multiplied by that number there. So I'm going to go ahead and write this out. I'm going to write down 18 times 2/3. I'm going to write the minus here because that's just an easier place to put it, times y over 2. And then on this side, we're going to have 18 times, I'll write negative y over 6. And then we've got 18 times 5/9. Okay, all right, looks pretty good. Let me make sure that looks like a y. There we go. Okay, now I'm going to change colors to do some cross cancellation. 3 goes in here once, 3 goes in here 6 times. 2 goes in here once, 2 goes in here 9 times. 6 goes in here once, 6 goes in here 3 times. 9 goes in here once, 9 goes in there 2 times. Now we can go through and we can figure out what we've got here. So this is a 6 times a 2, so that's a 12. This is a negative, don't forget that negative, negative 9. And remember, we canceled this off, so this is just negative 9y. Then on this side, this was a 3 times a negative y. That one is just in the denominator, so we don't need to worry about that. So negative 3y. And then we've got a 2 times a 5, so this is going to be a 10 over here. Okay, so again, we've gotten rid of the fractions, and again, I'm going to skip a little bit of the work on the next couple. Let's just quickly take a look and see how we could do this without writing out this step. The 3 cancels off the 18, it's a 6, so 6 times 2 is 12. The 2 cancels off the 18, this is a 9, so 9 times negative y would be negative 9y. The 6 cancels off the 18, this is now a 3, so 3 times negative y would be negative 3y. And the 9 cancels off the 18, that's a 2, 2 times 5 is 10. So it's actually quicker to do that as long as you follow all of that math than it is to write down each one of these. I'm not going to be writing that down in the future. We're just going to go ahead and solve this one here. So I'm going to add 9y to this side. I'm going to cross it off from there. I'm going to subtract 10 from this side. So I end up with a 2 on this side. And we end up with, let's see, what have we got here? We end up with a 6y. Yep, I think we're good there. So then we'll divide by 6, and we end up with y is equal to, this reduces to 1/3. So we go ahead and circle that, and we are all set. So let's take a look at these next ones. We've got C here, and you'll notice that we've got no denominator here. I mean, technically we could put a 1 there, and then we've got a 10, and then we've got a 5. And because this is in parentheses, this is all one term. So if we wanted to, we could have written that side as 3x plus 4 in parentheses over 5. So you'll notice there is just one denominator on that side. I'll go ahead and get rid of this right here. So this is what we're going to do. We're going to stop and think, I need to cancel off a 1 and a 10 and a 5. And this one's pretty easy. And again, if you don't want to write the 1, you don't have to. I just put it there so we could kind of think in that direction. So we need something that's going to cancel off a 10 and a 5. So the thing that will do that is going to be a 10. So we're going to multiply both sides by 10. So we'll put this right here, and then let's think our way through this. There's nothing to cancel off here, so this literally is just a 10 times a 2, so that's going to be a 20. The 10 cancels, so this is just going to be a negative 3x, so it's kind of cool when that happens. And then we multiply right here. The 5 cancels off the 10 is now a 2, so we've got a 2 times a 3, so that's going to be a 6, and then we've still got this x plus 4 in parentheses. So we'll go ahead and distribute here, and again, once we get to this point, it's just like normal solving, so we've got 20 minus 3x, we've got a 6x over here, and then we've got plus 24. We're going to move the 3x, so we're going to add 3x. So we'll get rid of that from that side. That means we're going to move this over to the other side, so we're going to subtract 24. So we get negative 4 on this side, and we get 9x over here. Yep, 6x plus 3x is 9x. Then we're going to divide by 9, so we end up with x equals negative 4/9. Go ahead and circle that, and we're all set. Now, this next one is kind of interesting because you'll notice that we've got a fraction right here. We've got 1/8 and then this nice stuff in parentheses there. And then this one is 0.75. So we're mixing fractions and decimals. So I guess we could answer this with decimals if we want. But again, once you introduce decimals in a problem, you're pretty much stuck dealing with the rest of the problem with a calculator. So let's do this. Let's think of this as, remember, that's a common rational number, 0.75. That's going to be 3/4. So I'm going to write 3/4 on that one right there. And then we just need to think of what we could multiply by to cancel off an 8 and a 4. Well, that's not too bad. We just multiply by 8. So watch what happens when we multiply by 8. Those are going to cancel, so we end up with a 1. So that would just be 1 times this stuff right here. So that's just going to be 2x minus 2. And then again, we get the same type of thing happening here. The 4 cancels with the 8. The 4 is gone. This is now a 2. So we end up with 2 times 3, so that's a 6. And then in parentheses is the 3x plus the 2. And then again, we're going to distribute and just solve here. So we have 2x minus 2. Distribute through, so this is going to be 18x plus 12. We're going to move the 2x to the other side, so that's going to be minus 2x. That means we're going to move that to the other side. We're going to do that by subtracting 12. So this is negative 14 equals, let's see, this would be 16x. So we'll divide both sides by 16. And those are going to cancel, so we end up with x equals, this is negative 14 over 16, so that's going to be negative. And 2 goes in here 7 times, and 2 goes in there 8 times. So we go ahead and circle that, and we're all set there. Okay, now we're going to look at this last type of problem. We've dealt with fractions a whole bunch. We kind of get that. Now we're taking a look at this, and it says, clear decimals from the equations, and it's done in a very similar way. So again, I'm going to circle this. Remember, you can only do this with equations. And then it says round your answers if necessary. So here's what we want to look at. The thing that kind of makes this difficult is we've got a decimal here and a decimal here, but no decimal right there. But remember, technically there is one, so I'm going to go ahead and put a 0.0 on there. And this is how we do it. We move the decimal the same amount on each one, so the coefficient is an integer. Remember, we want a whole number. It doesn't matter whether it's positive or negative or 0. We just want a whole number. And then, again, be careful when it doesn't look like there's a decimal because there really is one. So here's what we're going to do. If we could just scoot this over 1 decimal place, that would be a 2x. Scoot that over 1 decimal place, that would be a 26x. And scoot that over 1 decimal, it goes from being a 4 to being a 40. So this is negative 40 right here. And then we just go ahead and solve this. So we're going to move this on the other side. So we're going to, let's see, what would this be? We're going to subtract 26x. So this is going to be negative 24x equals negative 40. We'll divide both sides by negative 24. So those are going to cancel, and we get x equals, now that's going to be a negative divided by a negative, that's going to be a positive. We could spend some time figuring this out. Gosh, this isn't too bad. 8 goes in here 5 times, and 8 goes in there 3 times. So the answer is going to be 5/3. Now, I'm going to grab the calculator, and we're just going to check and see if we got this right. So let's see what happens here. If we do negative 40 and we divide that by negative 24, we end up with 1.66667, which we need to change to a fraction. So we'll hit the math button, change it to a fraction, and there's our answer right there, so 5/3. So we did get the right answer. The answer there's 5/3. Now we'll turn our attention to this one right here, and I'm going to go ahead and make this bigger again. We'll bring up the calculator if we need to. So on this one, let's see what we've got. So we've got this negative 3.34 and 6.3, and then this is just a -6. Again, it doesn't look like there's a decimal, but I'm going to put one right there. And then this one's just a 3.4. So this one we need the decimal to move once. This one we really don't need it to move at all. This one we could get away with moving it once. And this one we've got to move it twice. Okay, so 2 decimal places there. But remember, they've got to move the same amount. So whichever one needs to move the most, that's what we do. So we're going to move over 1, 2. So this is going to be -334 times m. We're going to move this over 2 places. So if you move that over 2 places, we get plus 630. So it's interesting that on these problems right here, notice how big the numbers are getting. Okay, we can still deal with that, but we are going to have a calculator on these. We're going to move this over 2 places. So just pretend that I bumped that m out of the way. So this is going to be -600m. And then on the end there, we're going to go 2 places on this one. So this is going to be -340. Okay, so let's see here. We've got m's on both sides. I'm going to go ahead and move the 600 over here. So I'm going to add 600m. Whoops, need another 0 there. So 600m. Go ahead and cross those off. Move this to the other side, so that's going to be -630. Let's see what we can get away with here as far as calculators go. On this side, this is going to be, that's -900. That's -970, I think. Yep, we're good there. And then on this one right here, I'm thinking, let's see, that would be +200. Let's see, 266, I think. 266m. Now, just to make sure, let's bring up the calculator and make sure that we've got that right. So we're going to take a look at these numbers. I need -334, and I'm going to add 600 to make sure we got the right number there, so 266. And then we had -340 minus 630, so we end up with -970. Yeah, we're good there. So then to finish this off, I'm going to go ahead and divide by 266. So we're going to have m is equal to whatever that is. Now, that's a mess, but remember, this problem was written with decimals, so we're going to go ahead and write the answer as a decimal. On this one right here, let's go back and check this one. I just remembered. Hey, if that's 5/3, that's going to be 1.67. Okay, remember that one up there? When we did 5 divided by 3, we ended up with 1.66. We're going to round to the nearest hundredth on that one. Sorry about that. And then let's come back here and take a look. On this one, we're going to type in, and again, the cool part about this is because we know we're going to get a decimal, and we're totally fine with that. We're just going to type it in as a division problem rather than as a fraction, so we get this. So -3.646. So that 6 is going to bump that up, so we get -3.65. So -3.65. So we'll go ahead and circle that. And again, those are both decimal approximations there. So now that we've got the answers to both of these, let's talk about why this works the way that it does. It kind of makes sense that if you're going to move the decimal over one place here, you'd need to move it on each one of those. It just kind of seems like a fair way to do it. Move it over 1 on each one of these, 2 on each one of these. But the reason it works is because we're basically multiplying each side by a factor of 10. So we are multiplying each side by, and I'm going to put 10 or 100 or 1,000, depends on how many places we need to move it. So we're basically taking advantage of the same idea here. So on this one up here, on C, on this example, we multiplied both sides by 10. Here we multiplied both sides by 8. Well, on this one, if you're going to make the decimal move over one place, we multiply both sides by 10. So we multiply this one by 10, this one by 10, this one by 10. So we're using the exact same idea as we were up above. So it's pretty cool that it works out that way. So that ought to have you set for the assignment. Really good skill, because when you really need this, it sure comes in handy.